In this video, I am going to explain correlation and analysis of covariance using R. Covariance and correlation describe how two variables are related. Variables are positively related if they move in the same direction. Variables are inversely related if they move in opposite direction. So both covariance and correlation indicate whether variables are positively or inversely related. Correlation also tells you the degree to which the variables tend to move together. Covariance indicates how two variables are related. A positive covariance means the variables are positively related, while a negative covariance means the variables are inversely related. The formula for calculating covariance of sample data is shown below. So the covariance COV of x comma y, that is equal to sigma I is equal to 1 to n xi minus x bar into yi minus y bar by n minus 1. So x is the independent variable where y is the dependent variable, n is number of data points in the sample, x bar the mean of the independent variable x, y bar is equal to the mean of the dependent variable y. So you can determine x bar and y bar using these formulas. X bar is equal to sigma I is equal to 1 to n xi by n, y bar is equal to sigma I is equal to 1 to n yi by n. Let us see some example problem. Find the covariances between the data set x and y where x is equal to 2, 5, 8, 11 and y is 5, 9, 1, 4 and discuss the output. So the same thing you can obtain directly, you substitute in the above formula and you can obtain the value, or otherwise you can use the R program directly, you can enter and you can see the output. Now let us see in this R programming we are entering these variables. X tends to column of 2, 5, 8, 11 and y tends to column of 5, 9, 1, 4. Now simply you can type COV of x comma y, that is the syntax for covariance. COV of x comma y, x is the variable, y is the variable. Once if you enter, then the output will display minus 5.5. Here negative is came. So a negative covariance means the variables are inversely related. The variables are inversely related. Now let us see the correlation. Correlation is another way to determine how two variables are related. In addition to whether variables are positively or inversely related, correlation also tells the degree to which the variables tend to move together. In addition to whether variables are positively or inversely related, correlation also tells the degree to which the variables tend to move together. The correlation measurement, called a correlation coefficient, will always take on a value between 1 and minus 1. So if the correlation coefficient is 1, the variables have a perfect positive correlation. This means that if one variable moves a given amount, the second moves proportionately in the same direction. A positive correlation coefficient less than 1 indicates a less than perfect positive correlation, with the strength of the correlation growing as the number of approaches 1. So now if the correlation coefficient is 0, no relationship exists between the variables. If one variable moves, you can make no predictions about the movement of the other variable. They are uncorrelated. If correlation coefficient is minus 1, the variables are perfectly negatively correlated and move in opposite to each other. If one variable increases, the other variable decreases proportionately. A negative correlation coefficient greater than minus 1 indicates a less than perfect negative correlation, with the strength of the correlation growing as the number approaches minus 1. So to calculate the correlation coefficient for two variables, you would use the correlation formula shown below. So that is R of x comma y, that is equal to covariance x comma y divided by Sx and Sy. So R x y is the correlation of the variables x and y, and CO x comma y is the covariance of the variables x and y. Already we have seen earlier. Sx is equal to sample standard deviation of the random variable x. Sy is equal to sample standard deviation of the random variable y. So these standard variables we can find out. The covariance already given in the formula. Covariance is obtained x comma y is equal to sigma xi minus x bar into yi minus y bar by n minus 1. And Sx you can find out square root of sigma xi minus x bar whole square by n minus 1. And Sy, the standard deviation is you can obtain the square root of sigma into yi minus y bar whole square by n minus 1. So use these formulas, you can determine the covariance, and then you can find that correlation. Okay, these things also we can verify using the R program. Now let us see that example. Find the covariances and correlation between the data set x and y, where x is 2, 5, 8, 11 and y is 5, 9, 1, 4, and discuss the output. Now let us see that in R programming we are giving, so this is the input. R program we can give that this is the variables x is tends to column of 2, 5, 8, 11, and y tends to column of 5, 9, 1, 4, and the function COV of x comma y, if you enter, then minus 5.5 is come. So a negative covariance means the variables are inversely related. And the correlation, that is a COR x comma y, you can obtain here. Once if you enter, then it's obtained minus 0.4298056. So correlation coefficient is negative. The variables are perfectly negatively correlated and move in opposite to each other. Likewise, you can solve the problems, you can find out the covariance and correlations. Now let us see some problems. Calculate covariance and correlation for the following data set. X is given 2.1, 2.5, 3.6, 4, and y is 8, 10, 12, 14, and discuss the output. Okay. Now let us see the input to the R programming. We are giving the input is x tends to column of 2.1, 2.5, 3.6, 4, and y tends to column of 8, 10, 12, 14. Covariance xy, just you can enter, then output will be obtained like this. Output to the R program is, that is 2.266667. That is the value, output value for this given data set. So this is for the covariance. Now let us see the correlation. Now correlation input to the program. The same that x variable and y variable. The function is we have mentioned QR x comma y, that is the input. Now you can obtain output program is 0.979457. Okay, so these are the likewise you can verify using the R programming, covariance and correlations. Now let us see the second problem. The marks of 6 students are given below. Calculate covariance and correlation for this data set and discuss the output. Now, so two courses are mentioned here, mechanics, and marks are given, strength of material marks are given. The total there is a 6 students data is given. Now we can find out the covariance and correlation of this given data set. Now you can see similar to that programming, just to have to enter the covariance. First we are giving the variable x and y, that x value is 65, 76, 61, 86, 88, 70, and y value is 72, 67, 56, 94, 81, 98. Then we can enter covariance x comma y, then it obtained 94.4. And correlation is 0.52910. So if 0.5 more than that, the correlation is very good. If it is less, it's not that much. So that you can understand. Okay. So likewise, we can solve the problems based on this correlation and covariance. I hope everybody can understand this relation of correlation and covariance function.